Okay, here we go. Alright, so what you're going to do here is we're going to take 15 minutes of notes and then 15 minutes of an assignment and about 10 minutes doing an activity, because at these tables there's posters of equations that you're going to do an activity with a partner. And then it's going to be question and answer session. So you can ask me about any assignment or any sort of test, and then I'll help you out individually. But it's in order of the people who came in first. The person who came in first is going to give me their assignment, and we're going to do that together. You take notes on everything, okay? That's how you get the extra credit, is when you take notes on what goes on the screen and what goes on when we go over other people's assignments. All right? So any questions about that? Yes? You can use paper that I provided here. There's paper by the log over there. And the same rule applies. Please don't talk when I'm teaching. That way you guys can hear what I'm saying. All right? Okay, so today we're going to cover balancing equations. So take out a blank sheet of paper and title it Balancing Equations. And it's actually related to the mole. All right, now we've done this before, but I want you to do it again. So we have balancing equations. That's really blurry, isn't it? So we have balancing equations, and what we want to do is figure out where does the mole come into play. So where do you guys hear the word mole outside of class? So before you came to chemistry, we've done this before, but go ahead and... Okay, a mole on a face. That's correct. And where else do you hear the word mole? The animal. And where else? The food, mole. That's right. And what else? There's about 2 to 3 more examples. Think about movies. Where have you seen a mole? Okay, but that's chemistry related. We're just doing outside of chemistry. What about games? What games have moles? And you try to hit them before they go in the hole. Whack-a-mole. Good. Whack-a-mole. And the last one, when there is somebody who says, like someone joins the police department and they're actually like part of the mafia. What do you call that? Or when somebody joins the mafia and they're actually a police officer or an undercover agent. You know what the name is for that? When you're hiding and you're pretending you're somebody else? It's like spy, 007, but it's also called a mole. So undercover spy is also a mole. Undercover spy. So those are 5 definitions of mole, and chemistry also has 5 different definitions. What are some different definitions of mole in chemistry? Grams, good. Where else? What else? You were going to say it?
602.
Good. Good. Correct. How many zeros after the 602? 20.
7.
Close. 21. 21. So 1, 2, 3, 4, 5, 6, 7. 21 zeros after 602. Huge number. And what is that number used for? Is it used for people, cars, sand, pizzas? What's this number used for? Atoms. Tiny things like atoms, ions. What else does it say down there? Molecules and particles. Right? Whole lot of tiny things. We don't use a mole of French fries. We don't use moles of hamburgers. There's just too many. No one could eat that many, right? What's another definition of mole? Another one is a coefficient, and we're going to cover that today. Coefficient. And is that the number in front of a variable or after? Who remembers from math? It's the number before. In front of a variable. But the key word is number in front, because that's what we're going to do today. Another definition of mole is mole to mole ratio. That's what we cover tomorrow. Mole to mole ratio. And inside of that mole to mole ratio, there are wild cards. Like in Uno, there is those cards that let you choose which color you want. Well, mole is the same thing. It acts like a wild card. It can let you choose from grams, 602 with 21 zeros. They let you choose from coefficients. They let you choose from mole to mole ratios. It's a wild card, and in math terms, we call that conversion factor. It lets you choose what you want to use. It's a wild card. All right, so let's use it as a coefficient today. The mole as a coefficient. So let's balance this equation, but we're going to follow 3 steps before we do that. Let's write down 2 equations. Save some space for your coefficients. Now there's 3 steps that you want to always keep in mind when you use a mole as a coefficient. Step number 1 is count your atoms. Number 2, balance your atoms. And number 3, satisfy the law of conservation of mass. Otherwise, things wouldn't happen. This light wouldn't turn on. Our lungs wouldn't work. We wouldn't take in oxygen and release carbon dioxide, because this law has to come true. Right? Another way of saying the law of conservation of mass is what you start with is what you end with. And it just makes sense. Nothing really disappears and nothing really appears. There really isn't magic in science, right? You have to make something out of something, not something out of nothing. What you start with is what you end with. So let's start with these two equations and balance them. Step 1, count your atoms. How many NAs are on the left? How many NAs are on the right? Are they balanced?
Yes.
Good. How about your nitrogens? How many are on the left?
3.
3. And how many are on the right?
2.
2. So are they balanced?
No.
No. So to make these balanced, we need to make them both into what number?
6.
6. So what can I put here to make nitrogen into 6?
2.
A 2. If you put a 2, it becomes a coefficient, the number in front, 2 times Na and 2 times N3. Well, 2 times N3 gives you how many N's? 6. So if I start with 6 N's, I must end with how many N's? 6. How do I make 6 from N2?
3.
Put a 3. Now when we balance the N's, we have to balance the NAs. How many NAs do I have in the beginning? 2. How many do I end with?
2.
I have to end with 2, but how many are there?
1.
1. So what goes in front?
2.
A 2. Did we satisfy the law of conservation of mass?
Yes.
Okay, good. So that's how we balance equations. Good. Let's do the next one. Zinc. How many zincs are on the left?
1.
How many on the right? How many H's are on the left? How many on the right?
2.
So what should go in front?
2.
A 2. That changed our number to 2 H's and 2 Cl's. If we start with 2 Cl's, we must end with 2 Cl's. And do we?
Yes.
Yes, we do. So is the law of conservation of mass satisfied?
Yes.
Good. All right. We're going to give you a short assignment, and then move on to our activity, and then we'll do question and answer for the first 3 students that walked in and their assignments. So you're going to get your extra credit and your makeup assignment. It's like 2 in 1. Okay? Pretty sweet deal. All right. You're going to have to copy down these problems